Good morning, children. Today we are going to be looking at the various forms of energy. As you already know, we have covered the mechanical energy, okay, which is divided again into kinetic energy and potential energy. And in this, we have already seen what mechanical energy is. It is nothing but the energy which is stored in a body by virtue of its position or state of motion. Now, from this definition, we have learned how to define kinetic energy and how to define potential energy. When you define kinetic energy, it is due to the state of motion of the body. But if you talk about potential energy, we use by virtue of its position the energy. Okay, now, boys and girls, we've also seen the factors that affect potential energy and kinetic energy. In this case, we know that mass affects potential energy. We know height affects the potential energy. Also, acceleration due to gravity also affects potential energy. Also, kinetic energy is affected by the mass of a body, that how heavy it is, whereas also the speed of the object affects kinetic energy. All this was explained to you in the previous class. Now we are going to see how exactly do we calculate potential energy. We know that potential energy was being affected by the mass of a body. Yes or no? Yes. By the gravity. Okay, so if it is on earth, it will be affected by the gravity of earth and the height at which the object is placed. So imagine now I have an object which is placed on top of a table. Okay, so imagine it is placed on top of this table, and this object is always wanting to push itself down to the ground. What are the factors which affect this? So basically, the mass, okay, how much it weighs, is always pulling it down naturally. Next, after that, the amount of gravity that is acting on it. So earth is attracting everything towards it, so we know that some amount of gravity is acting, and the gravity of the earth is nothing but 9.8. After this, we know the height. Okay, so imagine this table from the ground is 2 meters high. How high is it? 2 meters high. Now if the table is 2 meters high, naturally it is going to also affect how fast the object will fall towards the earth if this table is removed from beneath it. Okay, so we have seen in the previous class, if I have the same box on a 5-meter table, okay, imagine the height of the table is 5 meters, then the object will fall much faster because it will carry more momentum. So potential energy is higher only if the height is higher. Now if we look at kinetic energy, boys and girls, it is affected by the mass and how fast the object is traveling, that is nothing but the velocity. Okay, here you see that I have already written what are the factors which affect them and how we can calculate the answers to potential energy and kinetic energy. Now, boys and girls, the next form of energy we will be learning about is heat energy. Are you familiar with heat energy? Yes, I am sure all of us are familiar with heat energy. It is the energy which causes us to feel how hot or cold our surrounding is. For example, if your mother is cooking in the kitchen, what will happen if you go and touch the vessel which is on the stove? Do you think you're going to feel cold? No, you're going to pull your hand away. Why is that? Because your body tells you that the object is carrying a certain amount of temperature which is not good for you, and this is known as how hot the object is. Similarly, if you go out onto the mountain and wear no woolen clothes, do you think you'll survive in the snow? No. So it is your body again telling you that it is cold outside. This energy which is surrounding us and how we perceive it is known as heat energy, or also known as thermal energy. Now, when we talk about heat energy, the biggest source of heat energy is sunlight. We all see it every day, and it provides us with various other forms of energy. Now, when we burn coal, when we boil water, when we use compressed natural gas, when petrol is burned, all of this produce heat energy. Okay, now boys and girls, so far we have covered we have covered mechanical energy, we have covered heat energy. Now the third one which we are going to look at is the light energy. Can you tell me what is light energy? If you look at it tangibly, it is very difficult. But if there was no light, could you see anything around you? Close your eyes for a moment and try to perceive the world around you. Be honest to yourselves. What do you see? It is dark all around. We cannot perceive unless we touch. Now, boys and girls, open your eyes and you see magically all objects around you are visible. How do you think this happens? Okay, so imagine you have an object which is lying somewhere. Okay, imagine this ball. What happens is light rays are coming and falling on that object and getting bounced off the object. Now they get bounced off in several directions. Okay, and depending on where you stand, okay, if your eyes are here, boys and girls, you are going to perceive these light rays which fall into your eyes, and you are able to see the object. This is nothing but light energy which enables you to see things around you. Now, what are the things which produce light energy? Sun is a natural source of light energy. Candles, bulbs, tube lights, all of these produce light energy. Okay, now photosynthesis uses light energy to produce what, do you know? Yes, it uses carbon dioxide to produce oxygen. If you answer that, very good. And we are able to breathe with the help of oxygen. So now, boys and girls, we have covered mechanical energy, heat energy and light energy. What is the next on the list? Yes, chemical energy. Do you know what chemical energy is? I am sure most of us have used it sometimes in our lives. You know, any energy around us which is happening chemically, okay, is known as chemical energy. Now, what is sir trying to explain to you? For example, boys and girls, have you used salt in your food? Yes, we all add salt to our food. Okay, salt is nothing but a form of a chemical, and this salt gives in us the sensation of saltiness when we eat our food, or it enhances the taste of the food. So now, boys and girls, there are various chemical processes in the world. For example, when you burn coal, when you burn petrol, when you burn diesel, and in our daily lives we use in our tandoors wood, so it is known as combustion. Rusting on metals, it is due to oxidation. Very good. Now digestion is also a chemical reaction where the hydrochloric acid present in our stomach is burning the food. Photosynthesis, I already mentioned to you. Batteries have chemical energy, right? Fermentation of wine or beer. Now, boys and girls, all of these are examples of what? Yes, they are all examples of chemical energy. Now that we know what chemical energy is, light energy is, heat energy is, mechanical energy is, we will look at the next one, which is sound energy. Okay, and this is the fifth on our list. How do you think sound energy is produced? It is produced with the help of vibration. Remember, last class I told you, put your hand in front of the speakers that you have at home and you'll feel something. Those are the vibrations that are causing the molecules present in the air to vibrate as well, and we feel it in our hands. Okay, and this energy produces the sensation of hearing in our ears. Now, before I continue, I want you to remember that you will be writing the various forms of energy in your notebook and write the definitions for them. Now, let us look at sound energy. How is sound energy produced? Boys and girls, when a guitar string vibrates, it makes the air molecules around it vibrate too. And this compression and rarefaction causes sound to be produced in our ears. Similar, piano keys when pressed cause sound. Tabla, okay, the membrane on top of it, if you hit it, it causes sound. Okay, all of them have the similar way of working. Speakers, they use electrical signals which are converted into sound waves. So now we know what sound energy is. So what is the next one on our list? Mechanical energy is done, heat energy is done, light energy is done, chemical energy is done, sound energy is done. Okay, now we have magnetic energy, boys and girls. What is magnetic energy? Magnetic energy is nothing but the energy which is attracting everything around it. Okay, now it is stored in magnets. Now where do we use this magnetic energy? In a car. Okay, we have something called a alternator which charges a car battery. Okay, that is made up of a huge magnet. Okay, it is an electromagnet. Now boys and girls, even planes, our credit cards or debit cards, we know poles, right? North pole and the south pole. So earth also has a magnetic field. It is used inside computers. On the fridge, you put up all these alphabets. Do you remember? Yes, they also have magnets in them. So magnets are used in various forms of our daily lives. Now, boys and girls, after magnetic energy, we are going to look at electrical energy. Do you think electricity is important? Yes, it is. Do you think you can survive without it? No. If there was no electrical energy, I don't think you would be having any online classes today. Right? Yes, we would not be able to charge our phones, we would not be able to charge our laptops. Okay, so basically, electrical energy is very important to us. And how do we use electrical energy? Electrical energy is the energy which is possessed by moving electrons. You can see it on the definition here. Now boys and girls, what happens is, in our daily lives when we talk about electrical energy, we use wires which conduct electricity. I am sure all of you are aware. Now, are you aware of the concept of electrons? Yes, we all know that the world is made up of atoms, and in the center we have something called the nucleus around which orbits are there. Okay, the nucleus consists of protons and neutrons. Okay, so protons and neutrons are inside the nucleus, whereas electrons are revolving around this. What are protons? Protons are positively charged particles. Neutrons carry no charge. Okay, so this is at the center, which is known as the nucleus. Now boys and girls, around these protons or around this nucleus, on its orbit we have something which is rotating around it, which carries a negative charge. This is known as electrons. Now when we talk about electricity, these electrons flow through the wire. Okay, so they flow in one direction. So how do neutrons or electrons flow? They flow through the wires in one direction. Okay, usually these wires are made up of metals which are good conductors of electricity, such as copper. Copper is a very good conductor of electricity. Now when I talk about electrical energy, it is used everywhere in our daily lives. Just now I told you laptops, so computers, portable phones, radio, TV. Now, do you think we use it in stadium lights? Stadiums have lights, right? Yes, floodlights have them, our torches have them, lamps use electricity. Okay, so now boys and girls, all of these objects that I have put up on the screen use electrical energy. Now, after electrical energy, we are going to be looking at the last one, which is nothing but nuclear energy. Now, you must have already heard about the tensions in between Israel and the other countries. Now, we have countries which possess nuclear power, and this nuclear power is nothing but the energy which is stored at the nucleus. Okay, just now I have explained what nucleus is to you. So now, boys and girls, the energy which is stored in the nucleus of atoms is known as nuclear energy. Now, when we talk about nuclear energy, they can give us energy which is abundant, or you can also call them unlimited. Okay, if you know about submarines, what are they? Submarines are vessels which go underwater, usually used by the army. Now, boys and girls, when we have something as a nuclear fuel, what it does, it gives off heat which is in turn converted into electrical power, okay, or it is used for cooling, or it can be used for various other purposes. Now that we have learned the various forms of energy, we are going to look at the way of conservation of energy. Okay, so we will look at them in our next class. Thank you for joining and paying attention to the entire class. Stay home, stay safe, and stay happy.